Good morning. Today's class we are going to discuss about the process synchronization. What is process synchronization? The process synchronization in multi-process system ensure that process can safely access and modify shared resources without any inconsistencies. Very important thing, it coordinate the execution of process to avoid problem like race condition. So it's mainly used to resolve the problem of race condition. What is race condition? Okay, the next question, what is race condition? When more than one process is either running the same code or modifying the same memory or any shared data, there is a risk that result or value of the shared data may be incorrect. Why? Because all the process are trying to access and modify the shared resources. This condition is called as the race condition. Okay, we will discuss with some example. Okay, here P1 and P2 access and modify the shared variable at the same time. What is the final value of the shared variable? Okay, it may be either a 6 or 4 depending on the order of the execution. This inconsistency is caused by the race condition where both process try to modify the shared resources without proper synchronization. Okay, this is the example for race condition. Okay, what are the elements of or the key sections in process execution? There are different key sections in process execution. We will discuss one by one. The first one is the entry section. Okay, the entry section controls when a process can enter its critical section. It is responsible for checking whether other processes are executing their critical section or not. The second key section of process execution is critical section. The critical section is the part of the code where a process access or modify the shared data or resources. Only one process should be allowed to execute in a critical section at a time. Okay. The third key section, exit section. The exit section allows a process to signal that it has finished its work. Okay, the last section, reminder. Okay, reminder section. The reminder section contain non-critical code that does not require, okay, synchronization or protection from the concurrent access. These all are the key sections of process execution. Next, we are going to discuss what is critical section problem. Okay, the critical section is the portion of the program, okay, that access shared data. Every process has a code segment, right? It is called as the critical section in which the shared data is accessed. To ensure synchronization, no two processes it should be allowed to execute in the critical section at the same time. The other process has to wait until the data is free to be used. The wait function mainly handle the entry to the critical section. The signal function handle the exit from the critical section. Okay, what are the requirements to be satisfied? Okay, for critical section. Okay, the first requirement is mutual exclusion. The mutual exclusion means what? Right? If a process PI, consider a process PI, it executing in its critical section, then no other process can be executed in the critical section because what? Only one process is allowed to enter a critical section at a time. Okay. Next one is the progress. If no process is executing in its critical section, there exists some process that wish to enter a critical section, then the selection of the process that will enter the critical section next cannot be postponed indefinitely. Okay. The third one is bounded waiting. What do you mean by bounded waiting? A process should not wait forever to enter inside the critical section. When a process submits a request to access its critical section, there should be a limit. There should be a bound, which is the number of other processes that are allowed to access the critical section before it. After this bond is reached, okay, after the limit is reached, this process should be allowed to access the critical section. Okay. What is mutual lock? Okay, mutual lock is nothing but mutual exclusion lock is a simple software tool that solves the critical section problem. It is a solution to the critical section problem. The mutex lock is used to protect the critical region and prevent race condition. A process must acquire the lock before entering the critical section. It releases the lock when it exceeds the critical section. There are two functions are used. The acquire function, acquire the lock. The release function, release the lock. Okay, this is the example. See, whenever a process want to enter a critical section, first it acquire the lock. Okay, once it execute the critical section, whenever it come out the critical section, it release the lock. There are two functions are used, we already discussed, right? Acquire function acquire the lock, release function releases the lock. Okay, thank you.